Today's linear algebra, 15th of November, 2024. Our book start from echelon form and low reduced echelon. The difference is when you in echelon form, you should make it from echelon or triangle, and there will be pivot. If you go to low echelon form, the low echelon form should be pivot should be 1. It's like same as low reduced echelon form is unique because if you think about fractions, 1/2 is irreducible fraction, and there will be 2/4, 3/6. There will be infinite format of fraction, but if you make it as irreducible fraction, it is unique. It's same as like that mechanism. Low reduced echelon form will be unique because we made pivot as 1. And next, maybe you should remember when we do elementary row operations, we can do replacement, or we can do interchange, or we can do scaling. Replacement will be replace R1 as R1 plus 2R2 or something. Interchange will be change rows. When we do row operations, it will preserve row space, but it will not preserve column space. I will give you an example. If R1 and R2 is independent, then R1 and R2 minus R1 is also independent. Next is rank and nullity. Let's think about 3x4 matrix and 3x3 matrix and 4x3 matrix. Rank A plus dimension of null space A should be n. You should be careful with usage of words when we say dimension of basis of null space. Let's say in 3x4 case, it should have 4 elements. In this case, dimension of basis of null space will be 4, but dimension of null space will be 1. And column A will be subspace of R3 because it has 3 elements. But dimension of column A, in this case, it will be also 3. Link this with pivot, number of pivot. It's same with number of pivot, and dimension of null space will be same with number of non-pivot column. In this case, it will be 3, and maybe it will be 0. If we say if it is 0, then it will be 3 for dimension of column A. It can be then, in this case, it could be 3. It could be no more than 3. Then in this case, it will be more than 1 plus. Okay, so what you should distinguish is between how many elements the vector has and what dimension the space is. Element vector has dimension of vector space is different. You should know the dimension of vector space, and its vector will have different values. And when you do LU factorization, remember it, A equals to LU, then we will replace A to LU, and we will calculate UX first. And there is in linear algebra, the most important thing is you should remember this sentence keyword. Vector that corresponds to space space made by solution. There will be also parametric solution set. then there will be space and there will be correspond vector space and there will be vector space and solution set. This is the keyword. So if you go to factorization, we already did factorization, LU factorization. So if we go to PDP factorization, which we say diagonalization, then we will factorize this by eigenvector matrix and eigenvalue matrix. How can we find eigenvalue? We should first make AX equals to lambda X equation. Then we can make characteristic polynomial. Then the determinant should be 0. Then we can find lambda 1 and lambda 2. Then after find lambda 1 and lambda 2, we can put it in characteristic polynomial. Then we can find corresponding eigenvectors. We can do a sanity check by A equals to PDP minus 1 is same with AP equals to PD. So we can do a sanity check like this. And another thing is x1, if eigenvector x1 and x2 is independent, they should be independent. So there can be inverse matrix. So we can do sanity check. And there is one theorem, which is if vectors are correspond to distinct eigenvectors, then V1 to V eigenvectors are linearly independent, which means we have different eigenvalues, then they are independent. So if they have different eigenvalues, then eigenvector will be independent. We can say the vice versa. If not P, it is kind of P equals to Q, we can ask, if not P, what happened? It can be maybe linearly independent or it can be maybe linearly dependent. For this, we should calculate this. And for diagonalization, there will be a lot of things we can make application. If I simply mention about application, in data science, there will be a lot of covariance metrics will be given. We can write covariance matrix in this format, 2x2 matrix. Then in this case, covariance matrix is symmetric matrix, which is P's inverse is same with P's transpose. And also rho xy, sigma xy is same as rho xy multiply sigma x multiply sigma y, which is sigma of x and y is dependent on the relation between x and y and each standard deviation of x and y. Rho x and y will be corresponds to eigenvectors, and sigma x and sigma y will be correspond to each eigenvalues. And if we go forward, the R2 in statistics score can be also represented as the angle between random variable x1 and random variable x2. We will see it again for today. Thank you very much.